what he says in Hemming says ki, it's like suppose I'm sending you the message. Okay? That message may be uh, uh, gone correct or maybe distorted. Like suppose I told you कि ये क्वेश्चन पेपर में नहीं आएगा. ओके एंड सपोज कि कुछ नॉइस में प्रॉब्लम हो तो मेरे पास मैसेज गया कि ये क्वेश्चन पेपर में आएगा, नहीं कट गया. दैट मीन मेरा जो मैसेज है वो तुम्हारे तक गलत पहुंचा, राइट? एंड तुम्हारे तक तो ये बहुत ज़्यादा गलत हो गया, राइट? So Hemming code is basically told the method, the scientist method of correction, that how can we detect that whether our code is correct or not. मतलब तुम कैसे detect करोगे that your getting that is correct or not, and how will you correct it. So first thing is कि अगर तुम्हारे पास कोई कोड पहुंचना है तो करेक्ट इट, राइट? तुम्हें क्या करना है, डिटेक्ट करना है कि दिस कोड इज, कि तुम्हारे पास जो कोड आया है वो सही है या नहीं. और अगर गलत आया है तो करेक्ट इट. करेक्ट, ठीक है? यहाँ तक बोलो. कोई डाउट? नाउ टेल मी, एनी डाउट अप टू हियर? नाउ आफ्टर दैट ही टोल्ड, जैसे हम कहते हैं, he told about 7 bit. 7 bit के अलावा 8 bit 9 bit होता है, but for the basic thing that is 7 bit. ठीक है? पेपर में भी मोबाइल में भी 7 bit. 7 bit, this is 5 5 6 7. So it will have a 7 bit code. ये 7 bit. अब 7 bit 4 bit का ही डेटा भेजो. डेटा तो सिर्फ 4 bit का है, बट इस कर रही हूँ that you will be able to detect correct data or incorrect data. ठीक है? So for this, first bit है that parity. वन पैरिटी बिट जो मैं एक्स्ट्रा बिट लगा रही हूँ, और चौथी है डेबिट 5. और एज आई टोल्ड यू 5 और बिट ये डी से डेटा बिट्स. और दीज आर द पैरिटी बिट. ओके, अंडरस्टूड? फर्स्ट टेल मी, एनी डाउट अप टू हियर? ओके. पैरिटी बिट ऐसा नहीं है मर्जी, लाइक फर्स्ट विल टेस्ट पर 1, then we'll have 1 is parity, have to that is the parity bit, then we'll have to refer for 2 is the parity. Okay, clear? Understood? Okay. Rest of the code will be data bits. डेटा होगा फिर 1 तो 1 1. तो मैं पूरा तुम्हारा कोड, बट फॉर दैट वी दैट विच पैरिटी बिट की क्या वैल्यू, राइट? ऐसे नहीं है कि मैं रैंडमली के भेज. so for this give the law that 1 is depending 5 7. Yeah, and here and P5 D7 P1 bits. So this number ये तुम्हें याद रखनी, because this is given by the Hamming rule. Okay, now see, according to this, D3 HD is 1, D5 is 1, So 1. They are considered for each parity. पैरिटी बनानी है। मणिपाल में पैरिटी आता है, वैसे दो टाइप्स की पैरिटी होती है, इवन पैरिटी और ऑड पैरिटी, दे विल मेंशन इट, बट इफ दे मेंशन कि पैरिटी से करना है, number of ones like here up to here we are getting number of ones, the odd number have to add one more, that it will become a one number. So for this we the p 1, correct. Now similarly, now can you tell me what should be the value for p2 over here? 0, right? Ideally it even number, तो 1 1 even number हो गया. Similarly d5 is 1, so d, so in this also have, okay. So from here we'll be able to detect that p2 for value 0, it here that p4 is and p, so what data, जो मुझे डेटा भेजना था, अब मैं कोड बना के ये 10101 so that no one will ever detect, इन्हें तो बता दिया, पता नहीं लगेगा, but I want to send it to, ठीक है, correct.
Yes, ma'am.
No, no, down this parity, correct or tell which, how will do this, 5 after that, okay. So after this, that, correct. Now you know that correct, what is, right,
Yes,
this seen one, right, the code parity,
ma'am.
okay, right. So p1 6 is a 1 cent, and similarly for again, correct. Now tell me, any doubt up to here? Now if the odd parity, then in that, matlab parity with it will be 1 always, and if then the parity bit is ये p4 p1 odd है, that means 1, and even parity में 1 only, okay. तो लिख लो is 1 1 binary, put it in decimal, okay. 1 0 कर 1 ऐसे कर 1 कर 0 कर 1 कर 2 1 1 plus plus that would be 5. Okay, if we'll फिफ्थ में प्रॉब्लम है. ठीक है, मतलब फिफ्थ प्रॉब्लम है. फिफ्थ कौन, राइट? तो वन की वन है तो वन की जगह आएगा करेक्ट को वन वन करेक्ट. हैमिंग कोड पे कुछ टाइप किया था.
Yes, ma'am.
पेनल्टी डन.
Yes.
Ma'am, once again, can you show the thing? Yes, ma'am. Thank you.
Maybe.
No, ma'am. Just the old papers, like the ones that you like of last year and stuff.
Any different paper from this paper, then send it to.
Yes, ma'am.
Exactly. Done? Niyati, done?
Doing, ma'am.
Raksh,
I'm Karan. हमें एक स्टेप के बाद समझ नहीं आता था।
five, one, right? Even depends on Niyat. So, what is that basically metal, side, semiconductor, effect, transistor. Okay. So, see, basically, first we'll have semiconductor, right? As you know about the semiconductor, it is divided into two categories. One is P type and another the N type, correct? So, after semiconductor, scientists combine the two types of semiconductor and form the new device that is diode. Now, after making diode will act as switch that if it will behave as a on, then current will flow. If switch is off, then current will not flow, right? In case of forward bias, this is the case of reverse bias. After this diode, scientists think that combining two semiconductors will make us such a new great device. So if we'll combine the three semiconductor, then that would be very good, right? The three semiconductor is N, okay, or we can make it like NPN. So technically, this is known as transistor. Okay, combining the three semiconductor with each other is known as transistor. Now after that, transistor is basically divided into category. One is the BJT, other one is the MOSFET. In BJT, there is a like BJT earlier before COVID, there it was in your it is not in your syllabus. Now it is MOSFET syllabus. Okay. Now see in the MOSFET they'll ask you question. One is the construction and working principle of MOSFET. Okay. Another question they can ask you the derivation of drain current, and another question they can ask you numerical based on. Okay. These from the topics maybe will get two question in Manipal, maybe get one question. So now let's study about the first question,
Yes, ma'am.
that is construction working principle. Now suppose if we'll have p-type substrate, p-type substrate will have p-type board. Okay, and in this p-type body have done n-type doping. क्या कर ली, n-type की डॉपिंग कर ली. डॉपिंग मीन्स एडिंग इट, मतलब पूरा तुम्हारा पी टाइप है और उसमें एन टाइप की डॉपिंग कर ली. क्लियर. देन विल ऐड अ प्लेटिंग लेयर एन मटेरियल. हमने इंसुलेशन ऐड कर दी सो दैट कि ये एन के इलेक्ट्रॉन्स एंड ये एन के इलेक्ट्रॉन डायरेक्टली इधर से उधर मूव ना कर पाए. ठीक है, इंसुलेशन कर दी. इंसुलेशन पर्पज यू नो दैट का electrons will not be able to flow. Correct. And that insulation is done of material silicon dioxide. After this, in this will have basically the three terminal. One is the gate terminal, one is the source terminal, and another one is the drain terminal. This gate, this is sorry source, this is gate, and this is drain. So see how exactly it work. Okay, after this, suppose we'll have three terminal. I'm giving you example how MOSFET work. It exactly works like a tap. Tap मतलब पानी का tap. Like from here, the water supply is coming, right? From the supply we are getting, and this is the thing which from where we can control the flow of amount of water, and water is so technically this one is source जहाँ से पानी की supply आ रही है. This one is drain where we are getting the supply of uh, water, and this is gate from where we can control the flow of amount of water. If gate is closed, कि अगर तुम टैप बिल्कुल बंद कर रखा है तो ड्रेन में पानी आता है. टेल मी, अगर तुमने टैप बंद कर रखा है तो पानी आएगा ना. सिमिलरली इफ गेट इज क्लोज तो यहाँ पे पानी आएगा, राइट. Here water means the flow of electron. Means if gate is closed, voltage across it is zero. Then in that case, drain drain current would be exactly equal to yes or no. Now suddenly started in the flow of tap. धीरे धीरे तुमने पानी का फ्लो मतलब टैप खोला. Then accordingly जितना तुमने खोला उतना तुम्हारे पास पानी आएगा. You'll get water accordingly. Yes or no?
Yes, ma'am.
Yes, ma'am.
Now in this case also, if you give the value for VGS, suppose 10, accordingly you will get some of the drain current. Correct? अब now the third condition, पानी खोले जा रहे हो, नल खोले जा रहे हो, खोले, but there is a flow of water up to a limit ना, एक लिमिट तक ही तो पानी आएगा, लिमिट से ज़्यादा तो नहीं आएगा. करेक्ट और नॉट? एक लिमिट से ज़्यादा आएगा नहीं आएगा. दैट इज saturation is up to a higher limit. Then after that drain current will saturate. Saturate means starting में हो रहा है, then will become constant, right? Same thing happen over. Now see, here will have p type substrate. Now tell me, in p type substrate will have maximum number of majority carriers of holes or electrons. Tell me.
Electrons.
Electrons, right? Then we'll have type will have majority carriers as holes. Okay, positive. Positive have positive have whole carrier. So that means we'll have less number of electrons. Correct? So now we are connecting the this. Now this VGS. Here the positive terminal, as you can see, positive terminal is there. Attract towards here negative charge or the positive charge will attract positive charge or negative charge. Tell me. Here the positive terminal is, so it will attract the negative charge, attract the electron. Correct? And more elected over here because they can't cross it. Why they can't cross electrons? Because as we already provided the layer of silicon dioxide. Okay? Hmm? Any doubt up to here? Now see after
No.
that यहाँ पे भी n है और यहाँ पे भी n है. That n region will diminish. Now see after that यहाँ पे भी n region और यहाँ पे भी electron. So when we'll have the depletion, when we'll have positive and negative combined with each other. Have you negative and negative combined with each other, then we'll have depletion here. No now, but when we'll have the wall, when V and n is. But now as you can case, here all the electrons is there, so n and n region. Here also n, so automatically this wall disappear. बार है ये खत्म हो जाएगी, यहाँ पे बहुत सारे इलेक्ट्रॉन आ जाएंगे. Okay? So now what will happen is also drain and positive. So in that case electrons are there in n region, तो ये electrons ऐसे flow होने like positive, ये ऊपर से ऐसे जाएंगे और यहाँ से ऐसे, because here will have positive charge, तो positive will attract electron, तो electrons ऐसे जाए. electrons यहाँ पे गए, तुम देख सकते हो यहाँ पे insulation flow and come over this path and move to this channel. Correct? So this is technically known as n channel. इसे हम क्या बोलते हैं? n channel. Now see if VGS value, okay, VGS की वैल्यू क्या कर रहे हैं? इंक्रीज कर रहे हैं. Then tell me, more and more number of electrons will be attracted over here, right? And if more and more number of electrons be attracted, तो ये चैनल की विड्थ क्या होगी? जाएगी, हो जाएगी ना, बिकॉज मोर एंड मोर, ज़्यादा से ज़्यादा इलेक्ट्रॉन उतनी वॉल डिमिनिश हो जाएगी. देन आफ्टर दैट more electrons will flow and then more current will flow. So ultimately drain current increase. Okay, take it vice versa situation. If we decrease the value of V, इसकी value decrease करी, then less number of electrons are attracted here, लेस नंबर ऑफ इलेक्ट्रॉन्स अट्रैक्ट होंगे तो पतली हो जाएगी वॉल, नैरो. Then in that case less number of electrons flow and then drain current also further. See, it's the similar case I told you. VGS बढ़ाओगे, drain current is zero. VGS increase, drain current increase. Then VGS increase further. After that, drain current will saturate. Okay. So this is how the MOSFET work exactly. Now graph is there. In this we have voltage, and on the y-axis have drain current, that is it. Here we'll have V, and in this we'll have take for different values of V. I told you this value further, suppose VGS value 1 volt, in volt, this value is 20. Take any values, this value, then 40 volt. Okay. So accordingly, current. So in this we'll have basically three region. One is the cutoff region, another one is the, this one yellow one is the region, and this the triode region. Or what is this region? Suppose as I told you, जब तुम्हारा टैप बंद है, current will, right, current will flow means this is equal to 0, so that is the cutoff region. So वाला cutoff है कि इसकी value is very less. Then after that, open tap according to your requirement, नल खोला, then have water, then you will have active region, normal काम कर. Similarly, after this, when you are continuously opening this tap, बहुत लगातार तुम ओपन करे जा रहे हो, करे जा रहे हो, करे जा रहे हो, right, then after that what will have, continuous से ओपन कर रहे हो के बाद क्या होगा, एक सैचुरेशन टाइम रीजन पे पहुंच जाएगा, मतलब एक लिमिट तक पानी इंक्रीज होगा, आफ्टर दैट ना ही पानी आएगा कांस्टेंट, दैट इज नो सैचुरेशन. तो स्टार्टिंग में करंट बढ़ रहा है ना, वोल्टेज बढ़ा रहे हो करंट बढ़ रहा है, करंट इतना था, VGS और बढ़ाई तो करंट और ज़्यादा हो गया, VGS बढ़ाई तो करंट और ज़्यादा, बट एक सर्टेन यहाँ तक बाद करंट इज गेटिंग कांस्टेंट. तुम कितनी वैल्यूज